Alright, so hyperbolas. Okay? If I would go to this website, and I'm not really going to go to this website because it's not as cool and interactive as the ellipse website. The only good thing about it is it describes a hyperbola as an inside-out ellipse. Okay? So if I were to do this as an ellipse, okay, and now I take that ellipse and I turn it inside out. So instead, I take this chunk right here. Actually, I should have gone in a different color. I take this chunk right here, and I take this chunk right here, and I spin them. Now let me see if I can do this. And I spin them. I get, oops, this way. Come on. I get my, and I move it back a little bit. I get my hyperbola. Okay? So that is a hyperbola. Okay? There are left and right hyperbolas. There are up and down hyperbolas. Okay? And the two equations that we have for them, we'll go right into what the equations are, because that's very important as we go forward.
Do we want these on a note?
Oh yeah. Oh yeah. Okay. So the two equations are x minus h quantity squared divided by a squared minus, notice how this one's minus. Circles was plus, ellipses was plus, hyperbolas minus. Y minus k quantity squared divided by b squared equals 1. And that, ladies and gentlemen, is for a left-right hyperbola. Okay? That one gets me the left-right hyperbola. The other one, the y minus k squared, quantity squared, over b squared, coming first before the subtraction sign, that is going to get me my up-down opening hyperbola. Okay. The true mathematical definition of a hyperbola is the locus of all points where the distance from any point to the foci, the difference of those distances is constant. Okay? So the difference of the distance from a point that is on the hyperbola to the two foci, you subtract those distances, and that is the constant number. Okay? And that would work for any point on the hyperbola. And it works when you go to the other side. The distance here and the distance there, you subtract those, and it is that constant. Okay? So it's like you subtract them and it's 5. And it will always be 5, or whatever it happens to be in that particular case. Okay? So that distance is always the constant. Okay? Where can we see hyperbolas in real life? You don't really see very much of them. Okay? I don't have a lot of examples of where you see them, because some of them you don't even really see at all. Okay? Like, for instance, the one that you can see is if you ever clicked on a lamp in a dark room, and then that got a nice lampshade on it. Okay, you get kind of a parabola above on the wall. If it's right next to a wall, you get that light parabola above. And if you've got nothing below and it's high enough up, you can see one below it too. Okay, so that's one. You can't really see a sonic boom because it's a shock wave, and it's a sound wave. But a sonic boom is in a parabolic form. Okay. An hourglass, the sands, like sands through the hourglass, so are the days of our lives. I think Days of Our Lives is still a soap opera on TV. Okay. The sides of an hourglass are in hyperbolic form. Okay. The McDonald Planetarium in St. Louis is in the shape of the building is in a hyperbola form. Okay. What?
I thought nothing.
Oh, okay. All right. And then radio signals. So this is radio tower number 1, and this is radio tower number 2. And then as the signals go out, okay, then you can triangulate from those where they meet. Okay. And that's in hyperbolic form. Okay. All right. So my goal now in the next 36 minutes is to graph 2 hyperbolas. Okay? And in order to do that, we have to build something. Okay? So if I were to go back to this slide, okay, what I can do in here is I can build oops, that one's off a little bit. I went down too far. I can build a box. And that box is going to be very important for me. And it's going to be very easy to build. Okay? So that's our goal today, is we want to build that box, because that's going to tell us exactly where the parabola goes. Or, hyperbola, not the parabola. That's so pretty short. So, this is the first equation of the hyperbola that I would like to graph. Okay? Quantity x minus 3 squared divided by 9 minus quantity y plus 2 squared divided by 16 equals 1. Okay? Oops, that reminds me, I forgot you had said we need some graph paper. Now, in the past, when we were dealing with a parabola, we started with finding the vertex. When we were dealing with a circle, we found the center. When we were dealing with an ellipse, we found the center. Okay? So it logically says to us, let's find the center. But that's step 1. We got to do something first. And the very first thing that we are going to do is we need to mentally say, which way does this hyperbola open? Either left and right or up and down. Okay? And it all is determined by which squared variable is before the subtraction sign. Okay? So in this particular case, if it's an x squared minus y squared, okay, then that is going to be a left-right opening parabola. Okay? Because the formula that we had from the very first slide said x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1 was a left and right opening one. If it's y squared minus x squared, then that is an up-down opening hyperbola. Okay? So before we even start looking at this formula, which way does this one open? Left-right. So this is a left-right opening, not an up-down opening. Okay? Right? Mentally in my brain, we have to do that. Okay? So and actually, when I don't believe I put it on the worksheet for today. Nope. I did put direction of opening on the worksheet. Okay? So it will be a question that I would ask then. Which way does this hyperbola open? Left, right. Okay? Then we can go on to step number 1. And the first thing that we are going to do then is now we are going to find the center. Just like we did in parabolas, circles, and then ellipses. Okay? So Colin, where is the center of this hyperbola? 3, -2. So that's just like before, where we think oppositely when it's inside a set of parentheses. X goes with X, or H goes with X, K goes with Y. Okay? So the center of this hyperbola is at the point 3, -2. Love it. So let's put that on our graph. 1, 2, 3, down 2. There is my center. I for sure will put it with a C because it's nowhere near. Okay? Much like the center of a circle, much like the center of an ellipse, it's not on it. Okay? It's inside of it. Okay? Step number 2 then now says we are now going to start building that box. Okay? So what we're going to do is we're going to look underneath the x squared term, and that's where a squared lies, is underneath the x squared term. We're going to take the square root of that, kind of familiar to ellipses, right? Kind of the same thing that we did there with ellipses. Okay? And that's going to be the left and right sides of our box. So underneath x squared is 9. I'm going to take the square root of 9, and that is going to be 3. So I'm going to build my box 3 to the left, 1, 2, and 3, and 3 to the right, 1, 2, and 3. But I'm not going to put points. I'm going to put dashes, okay? Because those are going to be sides of the box. That's the only part that I know so far. Okay? Clear so far? Okay. Let me get us back up to speed. 3, -2, and 1, 2, and 3, and 1, 2, and 3. So there's where we're standing now. Now we look underneath the y squared term. So underneath the y squared term is 16. So I take the square root of 16 is 4. So I go up and down 4 from the center. And again, I put dashes. Okay. Now I have enough. I've got the top, where the top is, where the bottom is, where the left is, where the right is. So I can build my box. Now, I like to build my box with dashed lines. Okay? You do you. Okay? Solid lines here. I mean, I'm telling you right now, we're going to have a lot of stuff. We're nowhere near drawing in our hyperbola yet. So dashed lines would probably be the best. But again, you do you. Okay? So we built the box. Okay? We looked underneath x squared to go from the center left and right. We looked underneath the y squared term to go up and down. Okay? Now what we can do is step number 4 says now we can draw the diagonals of that box, because that forms the hyperbola's asymptotes. The nice thing about hyperbolas is they will fit inside a set of asymptotes. So it's not like you have to guess where it's going to go out to, like a parabola. Okay? I'm going to give you the framework for them. So if you take a straight edge now, book, ID, side of a phone, side of a folder, okay, something straight, and you go corner to corner on the box that you just created, you will have the asymptotes of your hyperbola. and definitely go as far as you can with those dashed lines. Remember, asymptotes are dashed lines. Okay. Definitely want to go as far as you can. Now, those are lines that we can come up with the equations for those lines. Okay? So we need to have a little chat about the equations of those lines. The first thing that I will tell you is that the slope of those lines are going to be, one is going to be positive because it goes up and to the right. One is going to be negative because it goes down and to the right. And the nice thing is that the slope of those asymptotes is always b over a. Because both asymptotes go through the center, and to get to a corner, I would rise b, because that's where I got it from. B was how much I go up and down. So I rise b, and I run either positive or negative a, depending on which one I'm going to. So that's where the plus or minus b over a comes in. Okay? Sometimes you get lucky. And sometimes one of the sides of your box is on the y-axis. Okay? And that's important because that's b, where those corners would be b. Okay? Wake up. Okay? Okay? In this case, we got lucky. Okay? If we don't get lucky, then we've got to use the formula, and I'm going to have to come up with two of them. Y minus k, actually I don't need to put y minus k in a set of parentheses. The formula then would be y minus k equals plus or minus b over a times the quantity x minus h. That's point slope form using both of my slopes and the center point, h comma k. Okay? And we want those answers, or I would like those answers in y equals mx plus b form, which in this case, so if I'm looking here, this is one of my y-intercepts. Let me just put a dot right there, and a dot right there is my other y-intercept. So that y-intercept, looks like a bad y. This y-intercept is 1, 2, 3, 4, 5, negative 6. And this y-intercept is positive 2. Okay? That's nice, and it worked out well for us because it was on the side of the box, was on the y-axis. That's not always going to be the case. All right? So my two asymptotes, the first one is going to be y equals positive 4/3 x. That's the up and to the right one, so then that would be minus 6. And the second one is going to be y equals negative 4/3 x plus 2. And yes, you will have to come up with both equations for both asymptotes for all of the hyperbolas that you do. Okay? Both asymptotes, you have to come up with the equations. Okay? All right, so we got that going, which is nice. Next, we're going to identify the two vertices. They are going to be the midpoints of the sides of the box that we just made. Okay? So in this case, because it was a left-right opening hyperbola, or an x squared minus y squared hyperbola, we will need the midpoints of the left and the right sides. Okay? So the midpoints of the left and the right sides are going to be here, midpoint to the right side, and there, midpoint to the left side. They're going to be straight out, left and right, or up and down from the center. Okay? And those are the two vertices. So the two vertices here would be at 0, negative 2 is the left one, and 1, 2, 3, 4, 5, 6, negative 2 is the right one. Step number 6 now tells me that I can now draw in my hyperbola. And the nice thing again about that is if you followed steps 0 through 5, drawing in your hyperbola, everybody's in the room should be exactly the same. It goes through the vertice, and it hugs the asymptotes. So once you go through the vertices, then it hugs down the asymptote, and that's why everybody's is going to be the same. Okay? Because they're all going to end along the asymptote. Okay. Now we're going to take a pause here for a second. All right, there. So I just copied and pasted where we're at because there's a lot. That's a lot to redraw. So I wasn't going to redraw, but I can get rid of some stuff now. So I can get rid of. Whoa, back up there. Get rid of this. We don't need that anymore. Get rid of this. We don't need that anymore. Perfect. Okay. So the last thing that we need to do is we need to find the foci. Okay? The formula for these foci is a squared plus b squared equals c squared. Okay? Straight up Pythagorean theorem. Okay? A squared is always the number underneath the x term. B squared is always the number underneath the y term. Okay? So in this case, a squared is what? 9. B squared is 16. So 9 plus 16 is what? 25. The square root of 25 is 5. Okay? So C, the distance from the center to the focus, is 5. So if I go back up to my graph, the focus, the foci are inside each individual curve. So the distance to the focus is going to be left and right. 1, 2, 3, 4, 5 is going to be one focus. 1, 2, 3, 4, and 5 is my other focus. So there are my two foci because they're inside the curve. Okay. So I would add and subtract 5 to the x part my center. 3 plus 5 is 8. So one focus is at 8, negative 2. 3 minus 5 is negative 2. So the other focus is at negative 2, negative 2. And that's everything that we need for a hyperbola. Okay? What I'd like to do now is I would like to graph this one. Okay? And we'll do it together. Y plus 3 quantity squared divided by 25 equals, minus x minus 2 quantity squared divided by 4 equals 1. So, let's see. Sophia, I think we're up to you, because I think Colin, you answered a question, right? Sophia, did you answer one yet? No? Okay. Which way does it open? Up and down, because it's y squared first. Okay. Yep, so this one opens up and down. Love it. Ooh, where's my center?
Negative, or 2, negative 3.
2, negative 3. Which is right down there. That looks bad. Make that look nice. Jenna? A. 2. Yep, because a squared is always underneath x, so the square root of 4 would be 2. Yes. Sam? B.
5.
5. Square root of 25 is 5. Yep. Okay. So from my center, Robbie, left and right 2 or left and right 5? Left and right 2 because that's A. Yep. Okay. So I put a little dash, 2 and 2. Hey, side of the wall is on the y-axis. That's good for when we're coming up. Jacob, up and down how many? 5. Yep. Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Gotta go scroll down a little bit more. 1, 2, 3, 4, 5. Okay. Gives us enough to draw in our box. Love it. Russell, what would you do next? Okay, we could find vertices now, sure. Whatever you want to do. You want to find vertices or you want to find something else first? Okay, so since it opens up and down, where are the vertices going to be?
Actually, a little dark on here.
Okay, Shaquia, where are the vertices going to be? Top and bottom. Yep, midpoint of the top and the bottom because it opens up and down. So that's going to be straight up from the center and straight down from the center. Okay? Antonio, could you give me the coordinates of those two orange points? 2, 2. Negative 8? 2, negative 8. Yep. Love it. Okay? Dietz, what do you want to do? Because why are the diagonals? Or what are the diagonals? They're the asymptotes. Yep. So that would have been, that's our other option. And again, drawing the asymptotes or finding the vertices, those can be interchanged because they don't, one doesn't need the other one. Okay? Right? So Russell, that would have been your other choice here. Okay? You said find the vertices, which we did, and that's fine. Other choice would have been draw on the diagonals. Okay? I'm going to scroll down just a little bit so that I can extend those. Scroll down. Bless you. Okay. Savannah, do you want to come up with the equations of the asymptotes right away? Yeah. Okay. Do you remember how to find the slope of the two asymptotes? Okay, we could count. We rise over run, right? Or I gave us a formula. The slope is always, let's hear, b over a. Yeah, plus or minus b over a, right? Okay, so in this case, the slope is going to be plus or minus, what's b? What's a? So it's plus or minus 5/2, right? Agree? Other Sam. Got to find the two y-intercepts, right? And we're lucky because we got a side of the box on the y-axis. Okay? So this top one has a y-intercept of, and this bottom one, -8. Love it. Okay? Mad dog. Nope. We're still got to find the slope. We still got to find them, right? So one is going to be y equals what? Positive or negative? You tell me. Positive, so that'd be y equals 5/2 x. Now, I'm going to go off the bottom here. Which one has the positive slope? The left one or the right one? The left one. Okay, so that one has a y-intercept of, so then that's going to be -8. Okay? Right? Boo, that leaves, and y equals, so now we got to go -5/2, right? X. That's going to be this right one as I'm looking down here at the bottom, right? So I follow that one back up, and it's got a y-intercept of 2. So then that's going to be +2. Okay? Love it. Okay? Your choice, Brennan. There's two things that we could do. We could find C. Okay? Or our other one is we could draw it in. Okay? At either point in time, we can do that. Okay? So find C. What's the equation to go along with finding C? A squared plus B squared equals C squared. Okay? So C squared is equal to A squared plus B squared. Okay? Jacob? A squared? Which is 4. MDX, B squared? 25. So this is really 4 plus 25. 4 plus 25 is 29. But that's C squared, right? So Marls, what is C? It would just be the square root of 29 because there's no perfect square factors in 29. Love it. Okay? Up and down or left and right? Which way? Up and down. So the square root of 29 is a little bit more than 5, right? So that puts it here and there, right? Okay? Or if I scroll up just a little bit more, okay, I would add and subtract the square root of 29 to the -3 because that's the up and down of my center. So this is going to be 2, comma, -3 plus minus the square root of 29. With me? Love it. What's the last thing we got to do? We just got to draw it in now, yeah? Okay. So, starts at a vertice, hugs an asymptote. Hugs an asymptote. Starts at a vertice, hugs an asymptote. Starts at a vertice, hugs an asymptote. Done. That's it. Okay? So, going forward now, tonight on your homework and on Friday's quiz, the things that I will ask you for are, I will ask you for the opening, which way it opens. I will ask you for the center. Where's the center? I will ask you for the two vertices. I will ask you for the two foci. And I will ask you for the two asymptotes, along with the picture. Okay? Friday, I might not ask you for the opening because I might just get that off of the picture. Okay? But tonight, I noticed on the worksheet tonight, the opening is on there. Okay? So your homework this evening is the front side of this worksheet, 9.5. Okay, it's the hyperbola worksheet. Okay, just like the last 3 weeks. Okay, this won't be due until Friday, but I want the front side done, at least started by Wednesday. Okay. Again, I remind you that you have a formative tomorrow in the Resource Center. The last class decided that they just want 4 graphs for the formative tomorrow, and then with all the accompanying stuff. Okay? So it'll be 4 questions tomorrow. My guess is it's going to be graph a hyperbola, graph an ellipse, graph a circle, graph a parabola. Since that's 4, and there's 4 graphs.
So the front side's due Friday.
No, Wednesday. All of it's due Friday, yep.